Hey there, everyone. I've got a pretty cool topic for you guys today. This is all about vector databases and comparing them to another type of data store called Dataframe. There's all kinds of data stores out there, like MongoDB, that's a NoSQL database, or SQL Server, that's a structured, um, standard traditional SQL database. You have vector-based databases where large data frames, or not data frames, where um, large bodies of data are stored in a sort of like a vector, like a database, but has vectors which has coordinates. There's a good example called Facebook AI similarity search, FAISS. I found this online. This is a good typical type of vector-based database. There's a few versions out there. And basically, the searches are done very quickly and very efficiently because of the way the vectors are stored and the way that Python is able to retrieve the text in the embeddings or the data in these embeddings in these vector databases, right? So I'm going to take you through that in just a moment and compare that to a large data frame. A data frame is basically a compendium or a compilation of rows and columns of data. So it's easy to search, it's easy to do aggregation and some type of grouping by different criteria for a pandas data frame, right? A vector database is very different. Everything is based on vector coordinates and angles and um, different features of those vectors stored in the database. So it's very efficient to store the data and to retrieve the data. It's actually much faster than a traditional database. So these have their place in the data science world or machine learning world or engineering world, if you're into data engineering. They have their place. It's not for everybody, but let's just take a quick review or overview of what's a vector database and a data frame, compare and contrast the two just for your own edification purposes. Okay, so a vector database is a special type of database that retrieves high-dimensional vector data efficiently. So the vectors can be any shape, any size, right? They're pointing in different directions. These vector databases are very typically generated by machine learning models, right? So it's not that easy to set up and to interact with for a person, but for a machine or for data engineer or data scientist, it's actually pretty easy to set these up and look at it. If you look at it as a person, it's not probably not going to make a whole lot of sense. But for storing and retrieving data, it's way more efficient than a standard traditional type of data store, like a data warehouse or a data frame, right? So you can store images, text, audio, video files, any kind of NoSQL, right? So it's not standard SQL or not only SQL. You can do SQL types of commands, but it's not only SQL. That's what NoSQL means, right? If I type it out here, NoSQL means not only, N-O is not only SQL. You can store anything in that database, right? Images, text, videos, whatever you want. Now, a data frame is much more of a traditional structured data store. It's two-dimensional. You have rows and columns. It's tabular. The structure is in rows and columns in this type of environment. There's indices or integer indices that have custom labels for rows and columns. You can do filtering, grouping, aggregation, transforming data into melting or wide formats, pivot or unpivot, things like this. And to typically the source is a CSV or an Excel file or a data table, a database or something like this, right? So let's go ahead and run some simple code here and create a data frame. So Control Enter to run it. Okay, and I'll share all this code with you guys later today when I post the video. So here's our data frame, 5 rows, 768 columns. Actually, that is just the head. Let me see how big this thing is. It's going to be pretty massive, I think. This print. Okay, where you run it. And we have 10,000 rows, 768 columns. So it's pretty substantial. It's pretty big. It's not going to break the machine or kill anything here, but it's a pretty large data frame. So let's start creating a vector database, okay? And let's take a quick look at what this thing is showing us. So Control Enter to refresh it. The first 5 vectors look like this, okay? So that's all the numerics, right? And again, it's different coordinates, different points, different angles for how this data is created and stored and eventually retrieved. Okay, so we have the FAISS vector database and the standard pandas data frame, and we're going to search both of them. Okay, so we have the start time over here, start time, minus time, which is now time, and we're going to look at this data frame in a column called similarity. Okay, and do we have that over here? We don't. Oh, we're going to create a column called similarity. So we're creating a new column based on the search criteria over here, the row values, and then the search vector. Okay, and we're going to measure the time here for the vector database search criteria to finish, and then for the data frame search criteria to finish. Control Enter to refresh it, and the vector database took 0.0525 seconds, so a fraction of 1% of a second, and this data frame took 1.143 seconds. So if I do a quick calculation, I'm going to estimate about 20 to 25% faster for the vector data frame. Just a guess, maybe 25%. Put that in there, 0.0525, 0.525, okay. And divide one by the other, divide by that, yeah. 21% faster. Okay, 21% faster for the vector database. So if you're doing large queries and large searches, 21% times faster is a pretty substantial number. So just keep that in mind if you're working with massive data sets, and you can convert all of your data into vectors and store that in a vector database. The storing, accessing, retrieval, warehousing of all the data is going to be significantly faster and more efficient than a traditional standard pandas data frame. Okay, so that's it. Pretty short video, pretty cut and dried. But I think we proved the point here and illustrated what we set out to illustrate here. So vector databases are very fast, very efficient for storing and retrieving database. The timing for both methods was based on time.time. You saw that over here. To get the current time and subtract that from the search time. So the takeaway here, FAISS or any type of vector database is great for storing large data sets because it's optimized for high dimensional vector searches. The performance is unparalleled compared to data frame storing and retrieval of data. Data frames will be slower, especially for very large data sets, because it performs brute force calculations for each row. So it has to search through every single row iteratively and then come back with a final result or present the final request that you make to that. With the vector data frame, everything is based on vectors. So essentially, you are looking at a very efficient index, and you know right where to go to look for the search criteria that you need to retrieve. It's a little bit like kind of like a telephone book. I don't think people really use telephone books anymore, but when I was growing up, we had those things. Or searching for people on your cell phone alphabetically. If you're looking for Bob, you're going to look for B's on your cell phone, right? Everything is going to be alpha sorted. If you're looking for Zachary, you're going to look at the Z's. You wouldn't start with A, B, C, D, E, F, G and work down to Zachary. You would just go straight to the Z's, right? That's what this vector database is. It's going straight to where it knows the data exists, and it fetches it and pulls it back, and you have your results 20 times faster than you have in a traditional data warehouse or data store like a data frame, where every single row and column needs to be iterated through to get the result. So that's it. Hopefully that was enlightening and useful and somewhat educational too. That was my purpose. I tried to do all these videos somewhat generic, but try to answer the question or validate the task that we need to, or run some models and get the results, and hopefully the model performs up to our expectations, right? Try to design all the videos to answer a specific question and present the findings to you guys, and then I'll share the code with you so you can do it for yourself, and then feel free to modify the code and change it to whatever you need to do, right, to answer your own specific questions or to meet your own specific needs. So that's it. Wrapping up now. Thanks for your time today. Enjoy the rest of your day. Goodbye, everybody.